to my channel, and in today's video we will be covering very basic fundamentals of chemistry. So in this video we are going to cover atoms, ions, structure of atoms, protons, neutrons and electrons, and how to calculate the number of electrons, protons and neutrons in any given species. So let's start the video. So first of all, as the definition is concerned, an atom is a basic unit of matter that forms a chemical element. So what is matter? As you're familiar with this term, so matter is everything that occupies space and that has mass. So everything that we can see around is made up of matter. All matter is made up of elements, and each element is made up of atoms. Each atom is made up of further subatomic particles called as protons, neutrons, and electrons. Protons and electrons, protons and neutrons, they lie in the center of the atom, and the electrons, they're electromagnetic particles, and the atom is surrounded by these electromagnetically bound swarm of the electrons, as we can see around. Okay. So as far as the size is concerned, atoms, they are very, very small particles. Typically, the size range is around 100 picometer across. If I give you an idea, like 1 picometer is, it's actually 1 trillionth part of 1 meter. So 1 trillionth part of 1 meter is 1 picometer. And each atom ranges somewhere around 100 picometers. So if just to consider an example, so we can also try considering this example by relating and comparing to the size of a human hair strand. One human hair strand is about 1 million carbon atoms wide. So I think this can be a good example to understand how small the atoms are. So in one human strand, there are 1 million carbon atoms. So width of the strand I'm talking about, right? So this is how small the atoms are. Each atom is made up of 3 subatomic particles called as protons, neutrons, and electrons. Protons, they are positively charged species. Neutrons, they don't have any charge, they are neutral. And electrons are negatively charged species. So as we can see, protons and neutrons, they lie in the center of the atom, and that center is called as nucleus. So this we can see in the center, this section, this part is called as nucleus. So protons and neutrons, they both lie inside the nucleus. Electrons are negatively charged species, and they revolve around, they make electron clouds actually around the nucleus. Protons are positively charged species, positively charged particles, and because their mass contributes to the mass of the whole atom. They're massive species and their mass contributes to the mass of whole atom. So protons lie in the center. Neutrons, even if they are neutral, neutrons, the word neutrons come from neutral. Neutral means they don't have any charge, so they are not positive, they are not negative either, they have no charge. And they are also massive particles, and that's why they also contribute to the mass of the atom. So when we calculate the mass of the atom, we will add the number of protons and the number of neutrons together. We will be covering this topic in the next upcoming slides. And the other particles that we see around here, they're around the nucleus, they're called as electrons. So electrons are negatively charged subatomic particles, and they are very, very small in size. They're comparatively so small in size and mass in comparison to the protons and neutrons that we don't even compare their mass to the mass of the atom. So when we calculate the mass of the atom, we don't consider the mass of electrons because electrons are comparatively very, very small in size and mass in comparison to the protons and neutrons. And they stay outside the nucleus. They are not inside. All right. So here in this table, so we can summarize certain specific properties of the atomic particles. So as we can see here, so electrons, they are specified with a symbol E, small e always, raised to the power -1 to represent that they are negatively charged species. They have charge of -1 and their mass is approximately, as we can see, very small in comparison to if we compare this the mass of the electron with the mass of proton and the mass of neutrons. We can see this is very negligibly very small size, very small mass, found of course outside the nucleus. Protons, we label them as small p raised to the power positive sign here on the top right corner. And that the positive sign on the top right corner represents that the protons are positively charged and their charge is +1. The molar mass you can see is 1.007825, roughly 1 unit inside the nucleus. Neutrons, they are represented by small n, no charge because they are neutral. And we can see their molar mass is approximately very close to the mass of the protons, roughly again 1 unit. They are also found inside the nucleus. So this is a kind of summary for the properties of the atomic particles. Atomic number. Atomic number of an atom is the number of protons in its nucleus. So atomic number of an atom represents the number of protons inside its nucleus. Or we can also say atomic number of an atom is the charge on the nucleus, because we know that protons are positively charged. So if we know the number of protons, that means we also know the nuclear charge. So nuclear charge means the charge on the nucleus. So nuclear charge will be dependent upon the number of protons, because neutrons residing in the nucleus, they are just neutral, they don't have any charge. So that suggests an alternative way to define the atomic number. So atomic number is the number of protons in the nucleus. So if for example, if we have any symbol, let's say carbon, so always the atomic, always the name of the element, symbol of the elements here in first letter is always capital uppercase. So as we can see here, carbon, right, C. Its atomic number is 6. So that means it has, how many protons would it have? So it will have 6 protons. So nuclear charge will be, so nuclear charge on carbon will be +6. Clear? So number of protons is equal to the number of the atomic number of the atom. So for example, in atomic number, if we see helium, helium has atomic number 2. That means it has a nuclear charge of 2+. All right. In a neutral element, that's very important. So in a neutral atom, the number of electrons is equal to the number of protons. Number of electrons is equal to the number of protons. What does that mean? This means that if we know the number of protons, means the atomic number, we also know the number of electrons in the same atom. So let's say if we know that neon is atomic number 10, and if it doesn't have any charge, that means the electrons are also going to be 10. So 10 protons, 10 electrons. If I say sodium. So sodium, if I say there are 11 protons because atomic number is 11, so that means there will be 11 electrons. Neutral species means, neutral atom means it doesn't have any charge. Now, how does a charge appear on an atom and what it is called as? Let's talk about that. So neutral atom means the number of electrons are equal to the number of protons. So that's why the atom will not bear any charge. But if the electrons are added or subtracted from a neutral atom, then the resulting atom is called as an ion. It's not called as an atom anymore. So if the electrons are removed or if the electrons are added to any neutral atom, it is called as an ion. Two types of ions are there, cations and anions. Cations means when the atoms lose electrons. So when atoms lose electrons, they are called as cations. For example, let's say we take an example of sodium. So sodium, in its neutral state, it has 11 protons and 11 electrons. Let's say one electron is removed from sodium. So how many electrons would it be left with? It would be left with 10 electrons, but protons still stay the same. So it will still have 11 protons. So that's why the charge on the sodium, now because there is one extra proton than the number of electrons, so sodium will bear a positive charge. So cations are positive even if the electrons are being lost. So this is not mathematical concept that the loss is negative. Loss is not negative here, because if the negative charge is removed, means electron is removed, there is one extra proton, means positive charge. Those positive charges go on the top right corner here. So the cations are represented by the positive charge on the top right corner. Clear? Anions are negatively charged species. That means when the electrons gain when the atoms gain electron, they become negatively charged species, and that's how they're called as anions. And how, for example, if I just consider an example of chlorine, let's say chlorine is atomic number 17, so it means there will be 17 protons and 17 electrons. Now let's say chlorine gains one more electron, so it will have 18 electrons, and there are still 17 protons. So that means there is one extra electron, so we will represent that as a -1 charge on the chlorine. So chlorine, anion, so now negatively charged. So we can see that anions are negatively charged species and cations are positively charged species. Right? So let's consider another example. For example, cations, as we said, that they are formed when the atoms lose electrons. So let's consider an example of aluminum. So we know aluminum is atomic number 13. That means it has 13 protons and 13 electrons in its neutral state. So if aluminum loses 3 electrons, so how many electrons it will be left with? 10 electrons, but there are still 13 protons. So there are 3 extra protons in comparison to the 10 electrons. So now aluminum will bear the charge of 3 positive. That's how we write the charges on the cations. Anions, another example if I can give you, for example, oxygen. Oxygen has atomic number 8. That means there will be 8 protons and 8 electrons in the neutral element. But when the oxygen gains 2 electrons, so there will be 10 electrons now, but still there are 8 protons. So that means oxygen has gained 2 extra electrons. So that will represent here as 2 negative. So the charge can be written as -2 or 2 negatives. Both are the same thing. But this is how we write the charge for the anion. So that's how the atoms, when they gain electrons, so they become negatively charged species. All right. So far, as you have learned how to find the number of protons and electrons in the neutral atoms and in the charged atoms called as ions. So now this is some practice for you, so you can pause the video for some time and try working on these questions. Welcome back. So after if you're done all the questions, or if you need any help, I have given all the answers at the end of the video, so you can check your answers and get some explanations if you want, if you still don't understand, at the end of the video. So now we will continue with the next topic, that is atomic mass. Atomic mass is represented by uppercase A, as atomic number is represented by uppercase Z. So atomic mass is represented by uppercase A. So what is atomic mass? Atomic mass of an atom is the total number of protons and neutrons. So the total number of protons and the neutrons inside the nucleus, because they are heavy particles, so they do contribute to the mass of the atom, so 1 unit each. So as is the number of neutrons, as is the number of protons, we add both of them together to get the atomic mass, also called as mass number. So atomic mass or mass number is same thing. So number of neutrons plus number of protons. So that is how, if you add these two together, we will be able to get the atomic mass. Other way around, if you want to get the number of neutrons, so you will need that in further calculations. So number of neutrons, how can we get? We will find the atomic mass from the periodic table. If the periodic table that you're using, it doesn't have the whole numbers, if the atomic mass is in decimal, so make sure you round it to the whole numbers, because number of protons and neutrons, they're always whole numbers. So atomic mass from the periodic table, or if it is given, so you will note that down and you will take away atomic number from that. Atomic number, as we know so far, is the number of protons. So either way, if you know the number of protons or you know the atomic number, so you will subtract that from the atomic mass. That way you will be able to get the neutrons. How do we, now because we have covered what is atomic number and atomic mass, so this is now a good time to understand how do we represent that. So this X I have used here as a symbol of any element. So for example, if I have chlorine as an element, so I will write chlorine in the center, atomic number at the bottom. So let's say atomic number is 17, atomic mass is 35, so I will write 35 on the top. Atomic mass on the top left and atomic number on the top bottom left. So this is symbolical way to represent the atomic number, atomic mass, and the symbol of the element all together. So if we want to get now the number of neutrons, so as the number of neutrons is atomic mass minus atomic number, so number of neutrons in chlorine element would be, chlorine atom would be 35 minus 17. So 18 neutrons are there in chlorine. Another example we can consider, let's say aluminum. So aluminum has atomic number of 13 and atomic mass of 27. So again, we will subtract 27 minus 13. So it will give you 14 neutrons. So there are 14 neutrons in aluminum. So likewise, so if you know the number of neutrons and the number of protons, you can add together to get the atomic mass. If you know the atomic mass and the atomic numbers, you can subtract them to get the number of neutrons. So this is some practice for you. So you can try filling up this table. So you can pause the video for some time and try filling up this table. So you will note down the number of atomic number from the periodic table, or if there is any other information given here in this table, so use that information to extract the atomic number from there. So for example, if the number of protons are given 8, then you know that the atomic number is going to be 8. So that's just a hint. So otherwise, you can use the periodic table to get the mass of the atom or the atomic number, and then if it is not given here, so then you can find out the number of electrons, protons, and neutrons. So try filling this table up. You can pause the video for some time. Key for practice 1. So if you got all of them right, so this is wonderful. If you have any questions, I'm just going to quickly review how do we find. So how many protons and electrons are there in the nucleus of these neutral atoms? So as the question says, these are neutral atoms. So number of protons, so that is exactly going to be the number of electrons here. Number of electrons. I meant to write electrons. So carbon has atomic number 6, so proton 6, electron 6. So for all of them, so because they are all neutral elements A, B, C, so carbon, copper, and uranium. So the given examples, they're all neutral elements. So that's why the atomic number will be equal to the number of protons and electrons. So no problem with that, I think. So then number 2, it says how many electrons are there in some charged species they have given here. So that means because the charged species are given, that means the number of protons are not going to be the number of electrons anymore. So magnesium, atomic number 12. So 2 positive means take away 2 electrons. So 12 minus 2 will be 10. Sulfur, 2 negatives, gains 2 electrons. So atomic number 16, gains 2 electrons, 18 electrons in total. Manganese, so it does have 4 electrons removed from it. Atomic number is 25, so 25 minus 4 is 21. So that's how we find it. For number 3, A says 1 electron is added to iodine. So of course, gain of 1 electron represented by negative charge, negative 1, I negative 1. 3 electrons are removed from aluminum, so aluminum 3 positive because the 3 electrons were removed. C says 1 electron is added to chromium 3 positive. So because here it is 3 positive already, so means chromium is in loss of 3. So if it is, there is one more gain, so that electron will balance out the present protons. It will neutralize the present protons, so the charge will decrease. So now we have chromium 2 positive. Electron is removed from sulfur 2 negative. So if it is removed, so the electron has taken away from it. So because it was in gain of 2 electrons, extra 2 electrons, that's why 2 negative charge is there. So if it loses 1 electrons, obviously the charge will decrease by 1. So S negative only, or negative 1. 2 electrons removed from copper 2 positive. So as it says, 2 electrons removed from copper 2 positive. Copper 2 positive, sorry, this should have been copper only, neutral. So if 2 electrons removed from copper 2 positive, so it should turn out to be copper 2 positive. Now, if you remove 2 electrons for copper positive, so then it turns out to be copper 4 positive, and copper 4 doesn't exist. So we have copper 1 and copper 2 as valencies. So there is correction here in this question. So either we can say 2 electrons removed from copper. So copper 2 positive ion will be formed. That was just an example. So now next question. The next practice you had. So I have just filled up this table. So magnesium, atomic number 12, atomic mass 24. So protons will be atomic mass minus 12 atomic number. So 12, 12, 12, because it is a neutral species. So electrons remain same as protons. So that's how it is. Cobalt 2 positive. So if you see atomic number is 27 and atomic mass is 59. So we can get it from the table. Number of protons will be obviously 27 because same as atomic number. Neutrons will be 59 minus 27, 32. And the number of electrons, because it is cobalt 2 positive, so it has lost 2 electrons. So 27 minus 2, 25. Chlorine 1 negative. So chlorine 1 negative means chlorine atomic number is 17, atomic mass is 35, protons is obviously supposed to be 17. Neutrons will be 35 minus 17 is equal to 18. And electrons are 18. Why? Because 17 plus 1, because there is gain of 1 electron as it shows in the charge. Same with oxygen negative. So atomic number, number of neutrons, number of protons, everything remains same here because it is 16 out of 8 is 8 neutrons. And atomic number of protons has to be 8. And the number of electrons exceeds than 8. Why? Because there is a gain of 2 electrons. So 2 negative represents a gain of 2 electrons. That's how comes out to be 10. Potassium, loss of 1 electron, we can see here on the top. So 19 is the atomic number. So atomic mass minus atomic number gives us 19 as number of, 21 neutrons. 19 protons, of course, that stays as the same as atomic number. And electrons are 18 because 1 electron is lost out of 19. So it should be 19 minus 1, 18. So that's all. So here in this video, you have learned about the atom, about the ions, what cations and anions are. You have also learned about how to find the number of electrons, protons, and neutrons in the neutral atoms, and in the charged atoms. So I hope this video really helped you out to understand this topic better. And if you really like this video, please subscribe to my channel and press the bell icon to because I will be covering all the topics next in for the chemistry and for biology, other subjects coming up, very useful coming up videos are there. So make sure you do subscribe to the channel and press the like button to get notifications. All right, thank you so much for watching this video. So take care. Bye bye.